And all the video is on my YouTube channel. So if you go to YouTube and look for my name, so you're able to go to my YouTube channel. Later, maybe I will show you. Okay, let's just jump into our class here. Let me know if you're not able to see anything on the screen. Okay. Okay, let's start, sir. Today will be our chapter 1. So I already briefed you guys on the basic information on this module. Okay. So again, so these are all my information. So just take note on the assessment, right? So 50% coursework, 50% final exam. You have 2 tasks, 1 group presentation and individual assignment. Okay, this one, and then 1 final exam there. So again, how do I come up with exam question? You refer to these 4 points. 1 question of each section. 1 question here, 1 question this one, 1 question this one, and 1 question this one. Okay, so just pay attention when I mention all these related to all these key points. Then you manage to score quite high in a final exam. Okay, so these are the scope for your final exam question. Let's look at chapter 1. Now, chapter 1, I'll be using these 2 books. So chapter 1 today, our lecture will be introduction. So we'll look at definition, we'll look at type of corrosion, what caused them, and what are the cause if you have a corrosion, what is the consequences, what is the price that you need to pay to handle corrosion, or maybe the machine breakdown, what is the cost. So these are the 2 books that I'm referring to. Let's start with definition. Now, if we talk about corrosion, try to understand that corrosion happen in metals and alloy. Metals and alloy. Okay, so how you memorize or how you remember what is the definition of corrosion? You remember the material that happened. You don't say plastic corrode, right? You don't say composite corrode, right? You don't say a stone corrode, right? You don't say water corrode, right? So you only say, this metal, this device made from metal and alloy corrode. So the best definition of corrosion, remember the first, what is the material? What material will experience corrosion? Metal and alloy. What is the action of corrosion? Action of corrosion is that, or effect of corrosion is destruction. It will destroy the metal and alloy. Okay, first, what is the definition? Ask yourself, what material will experience corrosion? Metal and alloy. So again, you already learned what is metal, what is alloy. So material is metal and alloy. What is the effect of corrosion? What happens if corrosion happens to the metal and alloy? It's a destruction process. Okay, destruction process. And textbook, they use spontaneous destruction. But if you use the words destruction, it still define the action. All right, and this and cause what? Cause all this lah. All this you can read lah. So important, you know, corrosion happen at what material? On what material? What is the effect when corrosion happen? It will destroy or destruction of that metals and alloy. Okay, so these are all the reaction. What happened in the process? Okay, from original stage to destruction. The process is all these lah. Okay, chemical process, electrochemical interaction, environment, biochemical, all this. Okay, so first, ask yourself, what is corrosion? Okay, so are you able to explain what is corrosion? These are all the support photo lah. I think you know what is all this lah. These are the oxide, and when you say the things corrode, you will see all these phenomena on the object. Okay, so we are clear with the definition. Next, we will look at what trigger the corrosion, what trigger the process. Okay. So this is a question you did ask yourself. What trigger the process? But before that, just now we define what is corrosion, right? What is the electrolysis process? What is the difference between corrosion and electrode process? Mean you learn in physics or chemistry, you know what is electrolysis, right? So what is the difference between corrosion and electrolysis? You have to differentiate, because some students, they learn chemical, they confuse between corrosion and electrolysis process or electrode process. Let me show you a diagram. This is the corrosion process. Okay, corrosion process. And what do you see on the screen here? You see a material. You see there's a electron, right? Electric charge. You see some product there, and then you see some color. So something different between electrolysis and corrosion will be they do not need external current, meaning you don't need to put in the power. Let me adjust my finger. Okay, you don't need to put battery or electric power to start the process. If you do electrolysis or electrode process, you need to put in positive, negative charge to initiate the process. So we go deeper about definition of corrosion. Material that involved is metal and alloy. And then what is the end result of corrosion? Is a destruction process that do not require external current. Okay, so this is some general picture about corrosion. And if you look at, let me give you a video. Okay, a video. Okay. So let's see. I think this one you've seen before. So you see what happened to this video. You see change of color. All right. You see this color. This process is corrosion process. That you do not see battery connected to the process. So what you see here is the corrosion process that produce color. In this case, blue and purple color, or slightly near to red color, purple color. So this is corrosion, one type of corrosion that involve, because different material will give you different color. So this is metal and one of the other metals material here. So okay. So let's look into these two diagrams. So let's say we have a sample of corroded sample, and this one is a top view, means you view from the top. You will see the blue color and the red color just now. So just now in this video, you will see, okay, you will see there's a change of color and different color here. So you'll see the blue and the purple color. So in this diagram, we just simplify it. Let's say we have a corroded section that you'll see blue color and red color. And then this is a side view, means you cut this one into half. You cut from the center. then you view from the side, you will see there's something happen in the middle there. Okay, so let's look at the process now. The overall corrosion reaction, we learned about chemical process here. Okay, so it will be very, very near to what you learned in electrolysis in physics or in chemistry class during your secondary school government exam, or SPM or STPM. So one of the chapter in chemistry is electrolysis. So here you need to recall all the chemical process here. Okay, so again, remind yourself, what is corrosion? Corrosion only happens in metal and alloy. So we start with a very basic chemical equation. As you can see there, you have metal, ferrum, plus water and oxygen. So from this equation, a chemical equation, you know that you can define corrosion. You need metal, you need water and oxygen. This is the most basic corrosion process. Okay, so you need metal, you need water, and you need oxygen. If you have water and oxygen plus the material, in this case metal, then the rest is that this is on the left side. You know that chemical process has left and right hand side equation. So this is before the process. So in corrosion process, metal will become ion. Water will break into, the water and oxygen will break into OH negative ion state. Okay, so on the left hand side, this one will be the initial process. This is, you need the ion, water and oxygen. And once the corrosion process initiate, you can see that the ion, you can see that the metal changed to ion 2+, and water and oxygen, they also change to oxide, OH negative. Then these two, when the material split into ion, at the end, they will join together. So how this one and this one join together? Okay, so the chemical or the ion combination, this one you need to flip back to your chemical textbook and also your previous two module, the metallurgy and one more material. Okay, so you need to flip back the previous textbook. So you join these two ions together, you will get ferrum oxide. So FeOH2. Okay, so this chemical equation is a corrosion reaction. So for this module, when it comes to test or when it comes to assignment, when it comes to exam, first things that we assess you, we'll give you a material. So again, very obvious, you won't see ferrum, you won't see ion in the, you don't see steel material in the exam. Okay, but what we will test you is that, let's say we give you another type of metal and alloy, then you explain the corrosion process. So you need to flip back how the discharge and charge happen, means how your chemical process happen. If you are given a metal, you're given a water, you're given an oxygen, you need to balance the equilibrium equation, chemical process. So this one already covered in your chemical and material class. So we won't repeat that derivation of equation in here. All right. So you just recall what you learned in your chemical class and recall what you learned in your material class. So this is the example when you're given ion or iron. You're given the iron with water and oxygen. This is the first chemical process that will happen. Any question for this chemical reaction here?
So far, no, sir.
No, huh? So
No,
far
sir.
very clear, huh? All right. Now, let me put this one as the first equation, and then we go further. Next one, we look at the ion, or look at the our metal here. So, you see, there's a technical name when your element Fe become ion 2+. There's one process we call, there are two reactions there. Anodic reaction, this the red color text there, anodic reaction. Okay, this is the maximum I can go before my finger broke away. Okay, so the first process, chemical process, we call it anodic reaction. What mean by anodic? Anodic means the products or the process, you will get 2+, you will get a positive ion, means iodic, and then you contribute electron. E negative means electron charge. Okay, so I think the name in the red, anodic reaction, I think you start calling back what you learned in the chemical process, anodic reaction. Okay, so when you have another process, okay, so I label this one as second equation. Second equation 1.2 is referring to anodic reaction. So sometimes in exam or test, we will ask you, we will guide you through, for example, question 1, section A, you're given the material, you're given the metal alloy, you're given the exact material. So you are given the periodic table, right? Periodic table, chemical periodic table. So explain the corrosion process with chemical reaction. So the first, what you do, you look at the periodic table, you derive or you develop the first equation. Okay, let's say you are given one metal, water and oxygen environment. So you get the first equation. Then the question will continue on to guide you through. The question will ask you, what is the anodic reaction in this question? Okay, in this scenario. So you develop the second equation where you look at the metal and metal become ion in the anodic reaction. In this case, our metal, ferrum, become 2+ ion and contribute electron, 4 electron there. Okay, again, if you don't understand why you get 2, why you get 4, please go back to your chemical textbook. Okay, we don't have time to explain about the charge and discharge, the orbit things, the orbit, how the 2+, how the electron, how many electron contribute, and all this. Okay, so you need to go back to the either the material textbook or go to the your chemical textbook. So if we have an anodic reaction, we will have another reaction that I circle with the green color. So anodic normally happen to metal, and water, oxygen, and this end products, OH negative there, we call it cathodic reaction that I label with green color box there. So what happened in cathodic reaction? So on the left hand side, you will see the water, oxygens. Where is this 4 negative from? From here. Where is this? Certainly why in the first equation here you don't see electron negative, but why suddenly when it comes to cathodic reaction, why suddenly there's a 4 negative there? 4 negative there is from equation 1.2, from the anodic reaction. 4 negative here, it contribute to this cathodic reaction. Okay, so when your water and oxygen plus the electron, extra electron because of the splitting of your metal element, you will get OH negative. It is from here to here. You get the third equation. Any questions so far? Any questions so far from the first one, second one, and third one? Okay, learn about the principle. Don't memorize all this because in exam or test, the element will change, environment will change. What I want you to learn today, this morning, is that try to ask yourself, are you able to derive the chemical reaction? If you're given the metal, you're given the trigger element environment. For example, in this case, you're given water and oxygen. So are you able to derive the first equation? Ask yourself this one. Second one, do you understand what is anodic reaction? Do you understand what is cathodic reaction? So far, everyone okay about this one?
Yes, okay, sir.
Yeah, okay,
Good,
sir.
all right. Stop me if you don't, anything on the screen here looks very weird or it doesn't make sense to you, or it doesn't make you understand, or it seems you have question on it. So just stop me and ask me question, yeah? All right. Next, we still look at the original overall chemical process. All right, the first equation. Let's look at oxygen now. Okay, so previously we looked at the red color box. We looked at the metal or alloy component, which give you the anodic process. Then we look at the environment element. In this case, is water and oxygen. You will get cathodic reaction. So there's one more when we learn about corrosion. There's one more technical word that you need to learn. I highlight the oxygen there. If your corrosion reaction happen in the acidic solution, okay, in the acidic solution, what means the acidic solution means the pH value is more than 7 or less than 7. What do you think? Okay, let me try to get your name. Okay. Okay, let me try to get your name. This is a general knowledge, question. Ngan Chinlong, are you there? Chinlong?
Yes, sir.
Right. So the wording of acidic solution. How do you define acidic water or acidic solution? The pH must more than 7 or less than 7?
Less than 7, sir.
Less than 7. Okay, good. So again, if you talk about oxygen depolarization, you need the help of acid solution. I highlight with the oxygen there. So now we look at the oxygen depolarization process. So this is this is the chemical term, technical term, but no choice because we learn about corrosion. Corrosion cannot run away from chemical process. So oxygen depolarization with the help of acidic solution, the chemical reaction will become this one. Okay, so how oxygen depolarize? We need oxygen, we need hydrogen charge, and we need electron. You need a positive charge, you need a negative charge to complete the depolarization for oxygen. Okay, so for oxygen plus positive charge plus negative charge, you get water. So basically, what do you mean by oxygen depolarization? You put oxygen, you pump oxygen into acid solution, you will get water. Okay, you get acid solution with pH less than 7, because in acidic solution, you have positive charge and negative charge inside there. So when you pump oxygen in the acidic solution, you know you will get water. Okay, oxygen depolarization, you get water. Try to link this information, try to link this information with corrosion process up there. Again, ask yourself, how corrosion process start? You need what? You need metal. You need environment. In this case, if you have water, you have oxygen, corrosion will going to happen. This is the process that contribute water in corrosion process. So if you have an acidic environment, you are contributing water, H2O water, in the corrosion process. Means you enhance, you encourage the corrosion to happen faster, because you are producing water for corrosion process. Okay, and the keyword to explain the water, where this water can come from, even you don't have water solution, means that you don't even have a water in first place. You get your water from oxygen depolarization. You get the fourth equation referring to oxygen depolarization with the help of acidic solution. Next is a cathodic depolarization. Let's look at a few. The first one is depolarization for oxygen. It can happen for any element, any environment element that happen in corrosion. So corrosion, you need two elements to start. One is the metal or alloy, and the one is the trigger environment element. So you can change either the environment, you use oxygen and acidic solution. Another one is let's look at hydrogen reaction here. Even inside the acidic solution, this one itself can contribute to the corrosion. You can see the ion itself, it will capture the electron inside the solution. So you simplify these two equations. The minimum ion that you need is 2H positive plus 2E negative to get hydrogen cell or hydrogen molecule. Okay, so this process is called hydrogen depolarization. So try to relate. Let me see. Try to relate equation 4 and 5. Do you see the pattern every time we mention depolarization? Do you see before the process? Depolarization, it will involve what? Negative charge. Okay, depolarization, it will involve negative charge. Means if the question asks you to write a depolarization for example, for oxygen, for hydrogen, for other gases, okay, for nitrogen, give you a hint. How do you know you write the correct equation? You look at equation 4 and 5. What is the similarity between two? What is the same thing? Is the electron charge. So every time before the process happen to the end products, you in the depolarization reaction, you need a negative electron or negative charge to combine the element environment corrosion environment element together with the charge, you get the products. So here oxygen, through the depolarization you get water. From this equation 1.5, you take the hydrogen charge, you'll get hydrogen. Another one, huh? When the metal deposition, this one is galvanized corrosion, is one type of corrosion that we will look into later. M means metal, so this one you can replace with ferrum, copper. If you look at the periodic table, sorry we don't have that on the screen here, but you should know what is periodic table. So in the periodic table, when you mention about it is metal, then it will be on the, if you have the chart, so it will be on the left hand side, right? It will be from the row 1, 2, 3, 4, okay, on the left hand side. Then you get a metal, okay? All right. So again, this is a very general equation. You can replace this M with any metal element or alloy element, but most of the time you will replace this M with metal element. For example, iron, copper. What else? All right. Can you give me a metal element? Name of metal element beside the metal, beside the ferrum, copper. What else? Logis, can you give me a metal element? Example of metal element.
So how about magnesium, sir?
Magnesium, correct. Good example. Sivendra, can you give me a metal element?
What about zinc, sir?
Zinc. Okay, good. Zinc also another one. Darshan, are you there?
Potassium, sir.
Potassium. Okay, good. All right. So good. All of you can give an example of metal. Again, after today, try to flip back what is periodic table, from a periodic table, how you define, how you identify metal element there. Okay, and because from the periodic table, you know how many charge will be contribute, or how many charge will be received or throw away. So try to review back the periodic table. So in this case, if you talk about deposition, metal deposition, I highlight the keyword there just to mention, just to remind you during test or exam or even assignment, it asks you to explain about something. So if you see the word decomposition and metal decomposition, usually you start with the metal plus the electron, you will get the end products or the element. In this case, this is just a general equation. Let's say let's say the element, the metal element, we only have one positive charge. So when you combine with one electron there, then you'll get the balanced chemical process. So this is the sixth equation. What happens if you have a metal ion reduction? Again, if we have a metal element with 3 positive charge, for example, aluminum, we have 3 positive charge. Okay, so again, if you don't understand why I say aluminum have 3 plus ion there, go and check the periodic table. Okay, so when you have a metal, again, this is a general parameter or general alphabet. You can replace M with any metal element with 3 positive charge. When the ion positive charge throw away electron, means contribute, not throw away, sorry, plus is not throw, plus is receive, plus is receive. So when 2 plus receive 1 electron, you get 2 plus, means you get more positive, less positive charge. Okay, less positive charge. Okay, so this process, when 3 plus become 2 plus, or maybe 4 plus become 3 plus, or 2 plus become 1 plus, the process is called metal ion reduction. Okay, so this is just a definition. So in the following class, every time we mention about metal ion reduction, this is the process. So in your in your mind, you should understand every time your lecturer mention metal ion reduction, it means there will be a ion, negative charge, combined with the positive charge, you get a less positive there. Okay, so these are the equation 1 until 1.7 is a concept or is a introduction of technical term that we will use for the following class. Okay, so let us see. So before we move forward, just to recap. Okay, just to recap, whether you understand the corrosion process. So first ask yourself, what is corrosion process? What do you need for corrosion process? You need an element. What is the element? Metal and alloy. What is the effect? What is the what corrosion can do to your element? Is destroy or it bring destruction. Okay. Through what process? So you have a lot of process, chemical process, biochemical. Later you learn about all this. Okay. So today I just want to prepare you on the technical definition. Okay. So just now we learned about anodic reaction, Cathodic reaction, depolarization. What is deposition? What is ion reduction? Okay, metal deposition means you get the metal element. Ion reduction means you reduce the positive charge. Okay, can we go a little bit more deeper? Maybe 2 more minutes, then we end the class. Is that okay?
Okay, sir.
All right.
Okay, sir. Okay, sir.
All right. Now, another scenario. Okay, another scenario. If we don't have depolarization reaction and we only have water, meaning we don't have oxygen depolarization process, we don't have hydrogen depolarization process, but we only have water. Okay, we only look at water. What happened? Water itself, when you can split water into ion, when you have extra negative charge in the water. Okay? If, for example, you put a metal on the table, a spoon, a metal spoon, and then you put in a lime juice, you put a drop of lime juice on the spoon, and you left it for a few days, you will see corrosion happen. Because of what? Because of water, it joined with the negative electron, you will get hydrogen and oxide charge, or OH negative. Means when water, it combined with negative charge, it will split to a new element. You will no longer see water, but you will see hydrogen and negative charge. You get the next one. So if you don't, if the process is you don't have acidic process, but there is a negative charge on the metal itself. So the metal will contribute these two negative charge to the water because you supply water. So the water will change to hydrogen and oxide charge, OH negative. Okay. These are the few examples. For example, just now, one of you mentioned zinc. So zinc, it will split into ion through ionic reaction. means you will get positive charge. Okay, zinc, you get 2 positive. So again, how you know this reaction? You look at periodic table. Again, if you don't understand what is periodic table, go to your chemical textbook, or later after this class, you go YouTube, look for periodic table explanation. Okay, yeah. So you get this one. Another example, copper. Copper, you get 2 plus means you get a charge there, and so on. Aluminium, 3 plus, and so on. Okay, so we have 3 process there, and there's a video there. Sorry, too loud. Okay, so you see the reaction of anodic reaction. In this case, is zinc. So let me stop the. Okay, sorry. Okay, so if you look at the schematic diagram here, what happened to anodic reaction? I choose zinc as example. Okay, I choose zinc as an example. What happened to the process of anodic reaction? Means that you will supply electron, right? You supply electron inside the electron will go and capture the electron is going to produce, for example, here, zinc become 2 plus. So when you have anodic reaction, the zinc itself, it's going to become charged 2 plus, and there's a chain reaction here. Okay, there's a chain reaction here. Means the 2 negative there will combine with hydrogen and so on. Okay, so this is just the schematic diagram where how zinc react when you have a how zinc produce positive charge when there is when zinc itself split into charge. When zinc is split into positive charge and negative charge, the zinc element, for example, let's say this section you have a 1 zinc. So when you have an anodic reaction, the zinc, this one, the zinc will split into 2 elements. So if you focus on this area, the positive, the zinc at this area will become charged, will become this one, and it will throw away electron, or it will contribute electron to the surface, because the electron will move to the shortest distance to grab another element. So in this case, you can see it will going to grab oxygen. Sorry, not oxygen. You're going to grab hydrogen in this case, and you'll get hydrogen. Okay, so this is the schematic diagram for zinc. Okay. So again, if you connect 2 elements in a solution, copper and zinc together, because of the anodic reaction, you see the element, let's say copper contribute 2 electron, zinc contribute 2 electron also, and because of the polarization, you will see that actually the current can flow, and you will see a loss of charge from one side to another tank. So if you are dip copper into a solution, you get a loss of copper positive charge in this side. You get zinc positive ion in another side, and because of the process, you will see current flowing from one side to another side. Okay, they will exchange electron. Okay, and here again, this is not electrolysis. Again, this is not electrolysis process because we do not supply external charges. This happens by their own because of their nature, because of their anodic reaction. Okay. Now this process also works if you put copper and zinc, you dip into, you take an orange, and if you have copper and zinc, of course zinc is very dangerous element, but if you're able to get zinc, so you dip these two and you connect the wire to LED, you will see the LED will light up. So because of the anodic reaction. This is another one. So if you use wire and you use a bridge there, I think this one you learned before in your SPM chemical class, where you will see that actually the process will also happen. You will see the light bulb will light up because of the bridge and so on. And this one we call it Daniel cell. Daniel cell that you learn in your SPM chemical class. Okay, Daniel bridge. Okay. Okay, corrosion can initiate by, okay, maybe you stop here. Okay, I end the recording and we continue our next class next week. Okay, let me end the recording.